So now you know how to find when LAN is going to happen. But we still need to know what we're doing and why it's important that we found LAN. I already told you that the use of LAN is because you can get your latitude automatically based off of the height of the sun. But we're going to break down why that's true. Now there's, in the textbooks, they will show you certain diagrams that explain LAN that I think are not that helpful. So I'm going to draw it my own way, and then I'm going to compare it to the textbook way. So we'll come up here. Let's assume it's the summertime and you're in the northern hemisphere. Why will become clear in a second. So there's the equator, and I'm going to say that's Greenwich right over there, so we have more workspace over here. Let's say you're right here. That's your fix. Now, earlier in the day, the sun's arc, the sun is going to travel right along this path over the course of the day. Remember, the sun's declination doesn't change much during the day. So in a single day, it's only going to move by maybe a minute. So its declination, which is its height above the equator, is almost exactly the same all throughout the day. It doesn't really change. But the sun is going to move, as a result, along this line. Now, when it's like here, your zenith distance, which is, remember, your distance directly from you to the sun, or from your zenith to the sun, which is the same as from you to the sun, is that. And your declination is that. Now, that's only important because your latitude is here. Remember, as we explained before, with these three values, you can calculate where the height of the body should be above the horizon. But we're not worried about that right now. We're just worried about the zenith distance and the declination as it moves through over the course of the day. So that's what it looks like in the morning. Later on in the morning, the sun's here, and you've got this zenith distance and this zenith distance. Then the sun gets there. Then, very specifically, at LAN, this is special, because at LAN, the sun is right there. And this is your zenith distance, and this is the sun's declination. And this is your latitude. To visualize, later in the afternoon, the sun is going to come over here. And then as the sun is going to be over here. And then the sun is going to be over here. But none of that matters. All this means, the only reason why any of this matters is because at LAN, when the sun is exactly due south of you, latitude is equal to zenith distance plus declination. Makes sense, right? And that can only be true at LAN, because LAN is the only time they're in a perfect line that is perpendicular to the equator. That's the only time that these three values have this relationship. At any other point in the day, the relationship between latitude, declination, and zenith distance is this, this, and this. You can use it to find your LOP, but it's not, it requires trigonometry, it requires work because you're creating this triangle here. At LAN, they're just a line. So all you're doing is addition. In this case, it's just latitude equals ZD plus declination. But to be fair, it's not always like that. Let's imagine the same situation, but it's wintertime. So we're going to say we're over here, just so we have a different spot to work with. And now let's say, because it's wintertime, this is the path of the sun. So during the morning, the sun's over here. That's your latitude. that's your zenith distance, and that's your declination. Now this is a weird shape, but you can still get your LOP off of that. It still works. The math can still work out just the same, but it's not anything special. Then we've got it later here. But then finally, we have LAN right here when the sun has the same longitude as you, or the same GHA as your longitude. And in this case, we have zenith distance, we have latitude, and we have declination. So in this situation, latitude is equal to zenith distance minus declination. Then we have one more situation, and this is the rarest. This only happens if you're in the tropics, very close to the equator, and it's the summertime. So let's imagine you are here this time, and just like before, as usual, earlier in the morning, here's the sun, latitude, declination, zenith distance. It comes and it's coming towards you. Finally, when we get to LAN here, we have latitude, zenith distance, and declination. So in this one, latitude is equal to declination minus zenith distance. All of this comes out to mean when the sun is exactly due south of you or due north of you, because all of this could be repeated in the southern hemisphere and it would make just as much sense. When the sun has your exact same longitude and the only difference is its latitude, there are one of three possible situations. Either you and the sun are in the same hemisphere and you are more towards the pole than the sun is. So in other words, it's local summer for you. Either you're in the north and the sun is in the north, or you're in the south and the sun is in the south. But you are further towards the pole than the sun is. The sun is closer to the equator, which is the majority of the time for the majority of people. In that case, latitude is just zenith distance plus declination. If it's the winter time, if you're in the north and the sun is in the south, or the sun is in the south, or the sun is in the north and you are in the south, doesn't matter where in either hemisphere, as long as you're in different hemispheres, then you do latitude is zenith distance minus declination. And finally, if you are in the same hemisphere as the sun, but the sun is further toward the pole than you are. Remember, the sun never goes above 23 degrees, 16 minutes north or south. I think that's right. That's the Tropic of Cancer and the Tropic of Capricorn. That's the furthest away the sun gets from the equator. If you are closer to the equator than that, and the sun is further to the poles than you, then you do latitude is declination minus the zenith distance. So the only thing you need to find is your declination and your zenith distance, and you get your latitude. Declination is written in the book, and you can find it in a second. Zenith distance is equal to 90 minus HO. So, if you measure the sun at LAN and you get HS, you go from HS to HO by doing dip, index error, main body correction, whatever you have to do. Now you have HO. You do 90 minus HO, and you get zenith distance. And then you plug in one of these three equations here after finding your declination, and you automatically have your latitude. If you get good at this, you could do it within seconds of measuring your site. You just automatically have all of it ready. Realistically, you can have the declination ready in advance because you know what approximate time you're going to be shooting it at. Now, these are the diagrams I like. These make a lot more sense to me. This is not the diagram that you're going to see it explained to you with, because Bowditch does it differently. The way they do it is if you place yourself in the center of the horizon, and you just say that this is your location on Earth. You don't even need to have the Earth visualized, but let's just draw it. That's the Earth right there. Straight up, here's your zenith. Straight down, here's your nadir. Straight across is the celestial horizon. And then they add in the equator, which, let's say you're in the north, so the equator looks like that, with that being the North Pole and that being the South Pole. They could throw the sun here, and then that's your zenith distance from the zenith to the sun. Here's the sun's... Oh wait, actually this is a bad example because you're on the other side. Sorry. I'm just gonna move where the equator is. Actually, we're gonna say, here's the North Pole, here's the South Pole, and this is the equator. So that's your zenith distance from you to the sun. So this time we're in the winter because the sun is in the other hemisphere from us. Here is the sun's declination, and here is latitude. So in this case, you get latitude is equal to zenith distance minus declination. You could also have, if you draw it again, zenith, nadir, northern pole, southern pole, and we'll put the sun, equator, we'll put the sun here this time. Then you have zenith distance, declination, latitude, and you get latitude is equal to zenith distance plus declination. And then finally, because I don't have enough room and also because this isn't as, you're basically never going to get this problem, but it does happen. Zenith, here's the center. Here's the North Pole and the equator. But then we're going to put the sun up here. And you've got declination, zenith distance, and latitude. So latitude is equal to declination minus zenith distance. That's the diagrams they use. I prefer these diagrams. I think it's a lot easier to draw these ones where you're looking at basically a chart of the whole world and looking at your position and the sun's position as opposed to being centered on you like this one is. But either of them work. And ultimately, the only thing you need to remember is if you and the sun are in the same hemisphere and you're above the sun, declination plus zenith distance. If you and the sun are in different hemispheres, if they're in different, declination plus zenith distance. If you and the sun are in different hemispheres, zenith distance minus declination. If you and the sun are in the same hemisphere, but the sun is above you, declination minus zenith distance. Those are the three things you need to know. And you just got to go from HS to HO, HO to ZD, which is just 90 minus HO, find your declination, and then do one of these three. And that'll give you your answer.